Okay, so today is about taking those giant factored problems that we did yesterday and then actually getting the answers. And a lot of times there's imaginary answers. And I know some of you are probably thinking imaginary answers are only good for like math teachers who want to play around with, weird things that would never happen in the real world. But here's a letter from a electrical engineer. And he says, I'm an electrical engineer, and so I can tell you there's often more imaginary numbers than real numbers in electrical problems. As you know, a complex number is a pair of numbers where one of the numbers is real and one of the numbers is imaginary. Imaginary numbers are not imaginary. They just don't belong with the group of numbers called the real numbers. When electricity flows through an electrical circuit component, like a light bulb, that resists the flow of electricity by using some of it to do work, the current flowing through the bulb is purely real and can be measured by a current meter accurately. But when electricity flows through other devices where no real current can go, the current flowing through that device is purely imaginary. If it were measured, the current flow through the device would show 0. So bottom line is, there are times when they have to use imaginary numbers to do their real work with electricity. Okay, and I guarantee you there were a lot of electrical engineers that were working on the iPad that you have in front of you right now. And they have to understand how, when electricity travels, that sometimes you use imaginary numbers to represent that. So anyway, the point is just that these imaginary answers are not just imaginary, they actually get used in the real world. All right. There's more proof on another letter, but I won't bore you with it. I think you get the idea that there actually are uses for this in the real world. All right, take a look at the purple one. Do you see 4 answers? Where do you look to find the answers? What are they called? The roots, the zeros. What else? X, what? Intercepts and the solutions. Yes, those are all the right names for them. And here they are. There's 4 of them. And I can see all of them. All right, that means that all of the answers were real. Now, on the next one, of course, they won't all be real. Look at the blue slide. Would you please turn your iPads to show me that you're on the blue slide? I want to make sure everybody's in the right spot. Some people are not turning their iPad. Please turn it rapidly. All right, thank you. Be there. All right, good. Now, on this slide, that one's real. So there's only one real. What are the other answers then? Imaginary. And notice that there's a little 3 there, so there should be 3 answers. One of them's real. There must be 2 imaginaries. And remember, I also have told you that imaginaries always come in packages of 2. Because when you're doing the quadratic formula and you end up with a negative underneath the root, there's always a plus and minus in front of it, right? Let's say I had that. Plus and minus the square root of negative 25. If that was in the quadratic formula, it would be giving me an imaginary answer that I would not see on this graph. All right, moving on. Same with this graph. Notice it's negative in the front, so it's going down on the right. And notice it's got a negative 5, which means it's touching here at the y-intercept of negative 5. The y-intercept is where x is 0, so all these terms would cancel out. Okay, so next thought about this one is it's got 1 root, but the other 2 must be imaginary because there's got to be 3 answers. All right, moving on. This one, I'm going to show you something that I think you'll help understand this better. I'm going to draw over this in blue. Do you get if my function were just shifted down a couple more spots that it would look like this? And then do you get that it would have 3 roots that you'd be able to see? And what if I shift it down even a little further? Now do you get that there's 3 roots that are all separate roots? What if I shift it down even farther? Do you see now it's still got 3 roots? A bounce and a cut through. All right. And if I shift it down even farther, then I'll be back in the same spot where I'll have 1 real one and 2 imaginaries. Okay, so you can think of it that way, that if I just take a graph and shift it down, it'll show me how many roots there could be. All right. You can't always see them, but if this last one would be the same thing. I can just draw this and go, and then I can say, well, if I shifted it down like this, you see how it would have 3 roots? Or like that, it would have 3 roots. Or like that, it would have 3 roots. So does that always work? No, because sometimes you can't see the imaginaries as like a little loop in the graph. So I don't want you to trust that method as always working. All right, get to the seafoam green page. So this one, for instance, has 4 roots, but I can only see 2 of them. 1, 2. And it's supposed to have 4. So there's 2 imaginaries, and I cannot see where they are. It's not like there's a loop in the graph that would show me. All right, so when I look down here at the actual solution, do you get, I've got 2 real roots here. And what are those 2? Imaginaries. 2 imaginaries. They always come in sets of 2. All right, I would like you right now to add a page. Insert a page, like I am here. And if you had this in the middle of your factoring and you had one term like looks like this, what do you do to solve it? Set it equal to 0. Everybody write that down. Say x squared plus 6 is equal to 0. And then solve it. Good at something. Most people get this far pretty easy. Then they go square root, and then they get x equals square root of negative 6. And some of them are smart enough to know that that's I root 6. But this is wrong. What did I forget? Yes, sir, Mr. V. Absolute value of x. So now I get 2 answers. X equals plus and minus I root 6. It's so easy to forget when you take the square root of an x squared that you get absolute value for an answer. That's why you have 2 answers. Okay, because if you had an absolute value, you're saying what's underneath the scribble here has to either be I root 6 or negative I root 6. All right, so anyway, I'm going to go back here and say, here's my answers. X equals I root 6, or actually, and x equals negative I root 6. Now I want to show you why this actually works. You know, the original problem would have had this as one of its factors. So I'm going to scroll back up and say, like, here's the other factor. Let's say it was like x plus 2. Obviously, if I put in a negative 2 there, that makes the whole thing 0. Do you get that? But why does it work that if I put a I root 6 in here, I root 6, why on earth does that actually equal 0? Think about this. What are you seeing? What are you seeing when you're seeing that? Yes. Yes. So when you take I root 6 and you square it, you're going to really take the I and square it, and the root 6 and square it. What's root 6 times root 6? 6. And what's I squared? So it's negative 1 times 6, which makes negative 6. And see how when I have negative 6 here and I add 6, it makes 0? That's why that answer works out. Okay, so these imaginary things actually work. When you plug them back in, imaginary answers like that and that actually will work. They will make it equal 0. Because I squared is defined, well, because I squared is negative 1. Remember that one. It's going to come up. It's going to come up in the ACT test, too. You're going to have a problem like that. And then you'll have to know, oh, and then let's say that that's equal to 5. And you'll just have to solve that, and a lot of people will be like, I have no idea what they're talking about. But hopefully you'll be able to say, oh, what's that part right there? Negative 1. So it's just 2x squared minus 1 equals 5. And then it's just 2x squared equals 6. And then it's just x squared equals 3. Sorry, 3 times negative 1. Sorry, thank you. So I better squeeze that 3 in here. Plus 3 times negative 1. So that would be, there we go, 2x squared minus 3 equals 5. 2x squared equals 8. X squared equals 4. X equals, be careful, plus and minus 2. Why? Because when you take the square root and the square root, you'd have absolute value of x, and then that splits into 2. 2 and negative 2. Okay? So that's just an example of where you'd use I squared in the real world on your ACT test. All right. Next thing. Turn around, please. We have a homework assignment where you had so far solved some big problems. Now you got them factored by using divide and conquer. I'd like to do one of those divide and conquers with you. Add a page, please. Nice, fresh, new page. Right now on your iPad. And on that page, I want you to try this one. Use divide and conquer. Factor that puppy. Since nothing goes into everything, we have to take it in parts. Just in case any other kids talk about what they're learning in math class, if you talk about divide and conquer, it's also called factor by grouping. But I like the divide and conquer analogy better. So then what comes out of these first two? 3x squared, very good. And what do you got left? X plus 2. And then what comes out of these two? 5. And what do you got left? And then the x plus 2's come together in the front. And then once they're gone, because really what I'm doing is dividing by x plus 2, divide by x plus 2, and they cancel. And what do I have left? 3x squared plus 5. Raise your hand if you got that right. Okay, good. Now, that's factored. The only thing you have to do for today is go back and solve all the ones you factored yesterday. So, like, you got them factored this far, so now you got to solve them. How do I solve this first one? That's easy. I just set this equal to 2. And I can do it in my head. It's negative 2. But that one I can't do in my head. So I'd set 3x squared plus 5 equal to 0. 3x squared equals negative 5. Divide by 3, x squared equals negative 5/3. Final answer, take the square root here, and I get absolute value of x is square root of negative 5/3. Oh, this is tough. And then absolute value of x equals I root 5/3. And the very last thing is to say plus or minus. Plus or minus I root 5/3. Whew. Is that one answer or two? That's two. Just plus or minus. So there's positive it and negative it. So there's two answers there, and there's one answer here. That makes a total of 3 answers. That's what I would have expected from something that had a third in it. All right, so moral of the story. Once you're done factoring, you're not done. Once you're done factoring, then you can take each of these parts and set them equal to 0. And get 2 different, or sometimes 3 or 4 different answers for them. All right, so now go back to your worksheet from yesterday. Find it in your remarks, wherever you saved it. One little just mental note, remarks does not save your work as you go. As soon as you go back, like if you were to write a whole bunch and then have your iPad crash, it wouldn't be there when you came back. But if you go back to the main screen for remarks, the place where you store all your stuff, anytime you go back there, it automatically saves whatever you were working on. So go back every now and then, yeah. Yep, if you go back so you can see your folders and stuff, it saved it. If you don't do that, it doesn't save it automatically. Okay, it's not like Google Docs where it's automatically kind of saving every few seconds. This thing you have to go back to the folders before it saves. All right, so anyway, go back to yesterday's homework, find yesterday's homework, and a typical problem. Would you read me the one you're working on there? Which answer was that? Number what? Okay, number one's answer. What did you get? And the fraction, or the factors, yes. All right, so on that, underneath it now, you just have to say, I'm not going to make you show work on these first two. They're really easy. X equals -1 and X equals 1. Okay, but on this one, you need to show some work. X squared plus 6 equals 0. X squared equals -6. And is it okay at this point to do a bunch of steps at once? Yes, it is. At this point, I hope you know when you do the square root of both sides, you'll end up with absolute value of X. Absolute value of X is equal to I root 6. I did a double step there. And you can do another double step to finish and just go right to plus and minus I root 6. Show some work, don't have to show all the work. Okay, now, did I get all my answers? Double check it. 1, 2, and that's 2 answers. Makes a total of 4 answers. That's what I was looking for. What part? Don't you get 1 answer, 2 answers, and notice how there's 2 right there, plus and minus. That's how it was. Okay, so the original problem had X to the 4th in it, and so I knew there were 4 answers to look for. 1, 2, 3, 4. Yes. Yes. I agree. I don't want you to have to flip back and forth. So if you can squeeze them in underneath. You remember how at the end of the hour I added a one that had more space on it? If you're using that one, great. If you're using the old one, that's fine too. Just get your answers done and make sure you show some work. That's the reason I added that one assignment that had more space. With extra, what I call it, I called it improved, I think. If you're using the one called improved, you probably have room underneath to solve them all the way. Yes? Okay. Hang on just a second. All right, so your only homework is, the only other part of this worksheet we haven't done yet asks you, how many times did this touch? All right, I need your full attention on this. Just flip your iPads shut. You'll be back to them in like 2 seconds, but I want your full attention right now. That includes you. We have to have a little chat about that. That's the second time you've been, what are you watching, videos? Or reading comics? Okay. Anyway, this has a question at the end of the assignment, and it'll say, how many times did it touch the x-axis? Some people might say, well, 4, because there was 4 answers. But no. How many times would this have touched? 2 times it would have touched. Because why? Because these are the only ones that would have touched because they're real. That would not have touched because those are imaginary. So it would have 2 times it touched or crossed the x-axis. It says crossed, just think of touched. All right, so if you have real answers, these are the ones that touch or cross the x-axis. The imaginary ones don't. So that last part of the worksheet, now you're assigned the entire worksheet, okay? And the last part is just asking about these answers. How many times would this have touched? This would have touched twice. Okay? All right, back to work. Finish your entire worksheet. Question? You can do it wherever you want. Just have all the answers.